Okay, 31. So for this section, we need a calculator, right? It's okay if you don't have it with you right now, but okay. Consider h prime, the first derivative. The graph has a local maximum where. So, I mean, I already graphed it and I even sketched it out. Like I have a little sketch of what it looks like. It kind of looks like this, like that, h prime. And if you want a maximum, you want to find a critical point where you go from positive to negative, right? From increasing to decreasing. So that's going to be this first one. I'm going to call it critical point 1, x1, whatever. The other one would be a minimum. But anyways, with your calculator, you find that critical point and it's 0.8. Okay. 32. The graph of f prime has a quarter circle, 2 line segments at x equals 2. I'm going to reemphasize that, at x equals 2, which statement is true. So, again, this is a derivative. At x equals 2, f is not continuous. Because we're looking at a derivative graph, that means f is differentiable. I can tell you that f prime of 2 is whatever this value is. I don't know what it is, but it's a value. And because the derivative exists, it's continuous. So, that was false. F is continuous but not differentiable. Well, I just told you that it's differentiable. F prime of 2 is something. You know, I'm just going to make up a number. 8. So, because I can see a derivative, it's differentiable. The mistake people are going to think of doing, they're going to think of trying to derive what they see. They're going to be like, oh, that's a corner. It's not differentiable. But what if you do that, you're trying to figure out f double prime of 2. They're not asking for f double prime of 2. F has a local maximum. Well, if you just look at the graph, then yeah, it looks like there's a max, but this is not f, and this is not a max. A local max would be at 3. The graph has a point of inflection. Yeah, because f double prime is positive, and then after 2, it's negative because the slope, right? The slope is positive and negative. So, that one. 33. 33 had a little typo, and I don't know if I told you guys, but it's supposed to be the integral of f of t. Okay. Okay. And here we're given the graph of f. This is the local linearization of h of x near x equals 3 is something. Local linearization is talking about doing a tangent line. What do we need to make a tangent line? A point and a slope. Let's go find something. Let's find the derivative. H prime of x equals f of x. And they said that we wanted a 3. So h prime of 3 equals f of 3. And if you look at the graph, f of 3 is 2. Right? Because literally, it's just a point. It's 2. We also said we need a point. So we need to find h of 3, which is the integral from 0 to 3 of f of t dt. Well, just go ahead and find the area under the curve. I see that we have a trapezoid, and we're going to end with a triangle. So, if you don't remember the formula for a trapezoid, you could also do a rectangle and a triangle, right? I'm going to do the trapezoid. A plus b over 2 times the height plus 1/2 base times height. I'm going to say this is A. 2 plus 1. So that means b would be down here. And the height is that. And I am going to write it as -2 because the area needs to be negative. Plus 1/2 base times height.
Wait, are we supposed to look for the area?
I should have just canceled the two triangles, huh? But now I'm too far in to go back. Yeah, so no, I was talking about these triangles, just kind of canceling each other out. Yeah. Anyways, simplify what I wrote already. My expression that would be -3 plus that would be a 1. So we got -2. So now I got my slope and I got my point. I can make my tangent line now. Y equals m, x minus x1 plus y1. But they have it in slope-intercept form. So then it's going to be 2x minus 6 minus 2, which gives us 2x minus 8. Okay. 34. Oh. I'll be right back. It's my timer. Maybe I should pause the video right here.